Welcome to the next installment in my video lecture series for managerial economics here at Rutgers University in Camden. And in this particular video lecture, I'm going to be looking at Chapter 10, Pricing with Market Power. In particular, giving you an example of a question very similar to text question 3.5. And that question reads, a monopoly book publisher with constant marginal and average cost of marginal cost equals 2 sells a novel in only 2 countries and faces the following inverse demand curves. In country 1, P1 is equal to 20 minus Q1. And in country 2, P2 is equal to 10 minus 1/3 Q2. What price would a profit-maximizing monopolist charge with a ban against shipments between countries? What would be its profits? So you have to realize that with the ban in place, there are 2 separate markets that this monopolist is selling to. It has a market in country 1 and a market in country 2. So with that ban, it effectively can segment the market and engage in group price discrimination. So this part's actually easy. All you're going to do is maximize profits in country 1 and maximize profits in country 2. And later on we're going to be talking about what happens if that ban is lifted, and that makes it a little more complicated. But realize that all we're doing here is maximizing profits in country 1 and maximizing profits in country 2 and adding those profits together in order to get what the joint profits are in selling in both countries, having a monopoly in both countries. So remember that we have country 1, where price 1 is equal to 20 minus Q1. And remember that total revenue is P times Q. So if I multiply P1 times Q1, so that's 20 minus Q1, the product of that, multiplied by Q1, multiply that through, I get total revenue is 20 Q1 minus Q1 squared. If I take the first derivative of that, I get that marginal revenue is equal to 20 minus 2Q1. And if I set the marginal revenue, 20 minus 2Q1, equal to marginal cost, remember marginal cost was equal to 2, so we get, for the profit maximizing condition, 2 is going to be equal to 20 minus 2Q1. 2Q1 is going to be equal to 18. Q1 is going to be equal to 9. And since I know Q1, I can place that back into the inverse demand function for country 1. So we're going to have 20 minus 9, so P1 is going to be equal to 11. So then we do the same thing independently for country 2. Total revenue is going to be price multiplied by quantity. So we end up with 1 minus 1/3 Q2, that product, multiplied by Q2. We multiply through by Q2, and we get total revenue is equal to 10 Q2 minus 1/3 Q2 squared. We take the first derivative of that, so we get the marginal revenue is equal to 10 minus 2/3 Q2. Remember, when we take the derivative, we multiply by the exponent and subtract by 1, so we're multiplying by 2, and this becomes to the first power. So 2 multiplied by 1/3 is equal to 2/3. Again, I know that marginal cost is equal to 2, and I'm maximizing profits, and the profit maximizing condition is where marginal cost is equal to marginal revenue. So I get 2 minus 2/3 Q2 is the profit maximizing condition. Solving for Q2, I get Q2 is equal to 12. I plug that 12 back into the inverse demand function for country 2, and I get a price of 6. So I know the prices and quantities for each country. For country 1, the quantity is equal to 9, and the price is equal to 11. For country 2, the quantity is equal to 12, and the price is equal to 6. So now I can take a look at these two and calculate the profits for each country. So I know that if I want to get total revenue is P times Q. 9 times 11 is equal to 99. If I want to get total cost, I know that average cost is equal to 2, so it's going to be 2 multiplied by 9. So total cost in country 1 is going to be equal to 18. And as I subtract total cost from total revenue, my profit in country 1 is going to be equal to 81. I do the same process for country 2. I get total revenue in country 2, which is just going to be Q2 multiplied by P2, 12 times 6. It's going to be equal to 72. Total cost is going to be equal to average cost of 2 multiplied by the quantity, which is 12, which is going to give me 24. And when I subtract the total cost in country 2 from the total revenue in country 2, I get a profit of 48. And when I add the profits for the two regions together, I get a profit total for selling to both countries of $129. Now realize that this situation is going to change without the ban. There is no ban of reshipping books across the borders of these two countries. This monopolist cannot effectively engage in price discrimination. So country 1 and country 2 are now one market. So we have to treat this as one market instead of two separate markets. So realize this, that in order to do that, we have to get the market demand curve, which means we have to add the demand curves for the two countries together. We were given the inverse demand function, so now we're going to have to solve for the actual demand functions. For country 1, it's just 20 minus P1. And for country 2, when we're solving for Q2, we get 1/3 Q2 is equal to 10 minus P2. We multiply by 3. And we get Q2 is equal to 30 minus 3P2. All right, so now we have the demand functions for country 1 and country 2. In order to get the market demand function, we have to add these two together. So we do that. We have the demand function for country 1, the demand function for country 2. We add those together. We get Q is equal to 50 minus 4P. And then we need to go back to the inverse demand function. So we are now solving for P. So we have 4P is equal to 50 minus Q. We divide through by 4 and we get an inverse market demand function for those two countries of P is equal to 12.5 minus 1/4 Q. So now that we have the inverse demand function, we can calculate total revenue, marginal revenue, etc. in order to finish out the problem. So we know that price is equal to that. If we multiply by Q, price times quantity, we end up getting that total revenue is 12.5 Q minus 1/4 Q squared. We take the first derivative of total revenue, which gives us 12.5 minus 1/2 Q. Again, remembering that we're multiplying by the exponent and subtracting 1 from the exponent. So we have 2 multiplied by 1/4, which is equal to 1/2. I have marginal revenue. I know that profit maximization occurs where marginal cost is equal to marginal revenue. And I also know that marginal cost equals average cost is equal to 2. So I could set marginal revenue equal to marginal cost. And I have marginal revenue of 12.5 minus 1/2 Q, marginal cost equal to 2. I set them equal to one another and solve for Q. And I end up with a quantity of 21. I can put that quantity back into the inverse demand function in order to get the price, which I did right there. You multiply that through and solve for P, and what do you get? You get a price of 7.25. So we have a quantity of 21 and a price of 7.25 when we don't have a shipment ban and we have to treat the two countries as one marketplace instead of two distinct marketplaces. Using that information, I can get total revenue. Total revenue is P times Q, so 21 multiplied by 7.25, and it gives us a total revenue of 152.25. Total cost is just average cost multiplied by Q. Average cost is equal to 2. Total cost is average cost multiplied by quantity. I know that average cost is equal to 2 and quantity is equal to 21. So 2 times 21 gives us a total cost of 42. And I subtract total cost from total revenue, and that gives me a profit of $110.25. So you can see originally when this firm was able to price discriminate, profits from selling to each market independently and maximizing profits in each marketplace gave profits of $129. When the ban was lifted and this firm could no longer price discriminate by segmenting the market by the two countries, its profits fell to $110.25.